Hello and welcome to Learn Data. It's great to have you on the channel. I'm Nilesh and today we'll continue learning about pandas and we'll look at some more examples about how to create visualizations using pandas. Especially today we'll look at how to create scatter matrix, Andrews plots, parallel coordinates plot, lag plot, radial visualization, bootstrap and autocorrelation plot. We won't go into the conceptual details of how these are created, but we'll look at the implementation as to how we can write a code to create these plots. So let's get into Jupyter notebook and start coding. Here I've already created a new notebook and imported three libraries: NumPy, Pandas and matplotlib. For data, there are a couple of data frames. You have the flash data frame from previous video. Then I've created additional data frames A, B and G. I'll put them in the description of this video so you can copy it from there. These are special case data sets, and therefore I'll try to create the plots with the flash data frame as well, but to show you what actually the plots can do, we'll also use these additional data frames today. Let's go ahead and first create a scatter matrix. And what a scatter matrix does is it creates a matrix of scatter plots, as we can see now. Now to use this particular plot, we have to import a library. So that is from pandas.plotting import scatter matrix. Once you have imported this, then you can go and run this command scatter underscore matrix flowers. That's the data frame we are going to use, and here we can specify the alpha to maybe 0.2, and we can specify the figure size to, let's say, 10 by 10, so it's a square matrix. And the diagonal values, we want it to be a KD plot, so it's similar to the histogram. And when we run this, we should be able to see a nice square matrix of plots. So here what we can see is the parameters that we plotted from the data frame: prod summer, prod winter, prod fall, prod spring, and also num orders. So each of these parameters are both on the x and y axis, and the corresponding scatter plots with those visualizations are also seen. For example, this plot consists of y axis that has num orders and x axis that has prod numbers. Similarly, that's the case with all other data sets, except for the diagonal parts where we have these KD curves. Those represent the distribution of that particular data set. So for example, this column of prod summer, this histogram is, or a KD plot is for that particular column. Then for winter we have this KD plot. So this is really helpful to quickly visualize if there are any correlations or if there is any dependencies between the independent parameters that we have in the data frame. In this case, we can clearly see that none of the summer, winter, fall, spring or num orders are related to each other in any way, because the scatter plots do not show any specific trend. They are all everywhere, as we can see. So that's completely random, and that's what we can conclude from that. We can also create the KD plot separately. So if we use the flash data frame and we try to use the column prod underscore summers, and then we go ahead and plot the plot.kde, then we can get the plot as we see here. On this plot, if we are wondering, we can also have the histogram. So if we type prod underscore summer and then go ahead and say plot, and or we can just say hist, and there we can see the histogram. But the x and y axis are going to be different. So let's go ahead and plot this here, and then we can plot the KD up there. So as you can see, at 260 there is the peak, and that's the peak right there. We can also create overlay of these two plots, but we won't go into those details in this video. That's the scatter matrix. Next, let's look at how we can create Andrews curves. So Andrews curves, and these this particular plot and a couple more that we are going to look at now are useful in looking at multivariate data. That's data having multiple parameters, that is multiple dimensions, and we can look at data clustering. Again, we need to import the libraries for this. So from pandas dot plotting, we need to import the Andrews underscore curves library, and now we can go ahead and write the command, which is Andrews underscore curves flowers. That's the data frame we are going to use, and we'll go ahead and plot just a few rows, not all of them. So let's just select the first 10 rows, and we need to select a categorical column. So that's the species at index 0, and then we'll select two more columns, 2 and 3 right here, and we'll also need to specify the category name of the categorical column we are going to use, although we have not specifically assigned it a data type category. I'm calling it categorical because it's the object column that we have in this data set. Now when we run this, what we see is these curves. So each data point, from whatever each data point is converted into a curve, and that we can see here. Now if there was a clear separation between each of these species, then we could say that they have some differences. However, here we can see that the aster green, it is separate here, but then we can also see green in this region as well. So maybe there's not much going on there. If we plot 100 data points, we can see they are all mixed, and so there's nothing really to pull out any species of clusters from this data set. They all appear random in nature. However, I've created a data set for the data frame A that's above, and this will help us visualize the what Andrews plot can show us. So if we type the Andrews underscore curve, and here if we use the data frame A and use the column capital A as the categorical column and run this, then sorry, this should be Andrew A and curves, it should be S. Okay, so here there are a couple of interesting things we can see. First off, what we can see is this jump in the curve for the segment O, which is labeled here in the legend. As we can see in the data frame, the values for O, they are much higher. They are in the range of 300, whereas all other values are much less. Maximum is around 150. So that's one point this particular plot is telling us, that there's something going on with this O data set that you need to look at. Next, what we can also see is that all these curves are going in this particular trend, right? Except this one curve that is going exactly the opposite of all other curves. That's telling us that there's some outlier or something not normal in the data, that's different in the data set that's going on. So if we look at, and that's coming from the segment N or category N, and here we can see that for N we have this one set of row at index 5 which is negative, and that's exactly what this is telling us. So because it is negative, it's going in a different fashion. So Andrews curves could be used in similar situations where you can look at run the plotter data set and see if there are any trends or any anomalies that we can identify and pick them out and use them for analysis or remove them from analysis as needed. So that was the Andrews plot. Next, let's look at parallel coordinates, and this is similar to what we saw above. First, we again need to go ahead and import the library. So from pandas dot plotting, we need to import parallel coordinates, and once we have imported this, we can now write the command parallel underscore coordinates, and we'll use the flowers data frame first, just to see if we can find anything. If not, then we'll use the other data frame that we have created specifically for this purpose. So we'll use 0 as the species category, and then I'm going to add these 3 additional columns right there. Again, as we did in Andrews curves, here we need to specify the categorical column. So I'm going to say species, and when we plot this parallel coordinates, I'm going to copy and paste this. Okay, so here what we can see is each of the column or parameter appears as a vertical line in this plot. So we have 3 columns, and therefore we have these 3 vertical lines at prod summer, prod winter, and prod fall. Again, these lines look mixed up, and so there's nothing really that we can see that could be a cluster in this case. If we add one more column, that can also be done. So they look all mixed up. So looks like the data is mostly random in nature. However, if we now use the A data set that we plotted above to see if that has any trend or clusters, we should be able to see that here, and we do see that. Similar to the previous plot, the Andrews curves, here we can see that the O is completely separated, and that tells us that the values are different and they are higher at 300. Again, this one data point is, or the row is completely negative, and therefore it's running in the opposite trend as compared to the rest of the data set, as we can see. So this plot, similar to Andrews curves, can be used to look at data clusters or anomalies in a data set. Next, let's look at lag plots. So lag plot, and what lag plot does is it tells us if the data is random in nature, or if there is any structure to the data. We'll again go ahead and import the library. So from pandas.plotting, we can go ahead and import lag underscore plot. Now we can write the command lag underscore plot flowers, and alloc. Here we can take all the rows, and we are going to skip the categorical columns. So we'll just use these numeric columns 2, 3, 4, 5 and run this. So as you can see, it depends on what you call a structure, but here there is no directionality. As you can see, there is a cluster here, there is a cluster here, there is a cluster here. So maybe that could be of interest. So this cluster down here, it could be representative of the production in winter, where the production is much lower, and that's probably what we could be seeing here. And let's go ahead and create a lag plot for the data set that we had specifically created for this, so which was the data frame B. Here we can see that the numbers are definitely in a specific order. So this is 1, 2, 3, 4, 5, it goes up to 6, and then it comes down 6 through 1, and the second column is similar to the first one, except that the signs are negative. So there's definitely some trend to it, and it's not random. And when we plot this, we do see that there is a specific structure to the data set, and we can see that in these lines, that definitely shows that they are following a trend. and this can be picked out from a dataset using a lag plot. Next, let's look at a radial vision or RadViz plot. And what RadViz plot does is it again helps us find if there are any clusters in the dataset. So we'll go ahead and import the library from pandas.plotting, import, and here we'll use the RadViz as a library, and then we type the command RadViz flowers.illoc, and we'll again go ahead and use the species column at index 0, and then use additional columns 2, 3, 4, 5, and finally we'll specify the species as the category in this case. Now once we have the plot, let's see. Okay, so this is the plot we have, and what this plot has done is all the 4 parameters that we had, or the column names we had, those are spaced in equidistance in a circular fashion around the circumference of a circle right here from this particular center, and the data points are plotted in the center. So if there is any affinity or relation that is more close to any specific parameter or column, then those points would have moved in that direction. But here it seems that there is no relationship between any of these, and the data is completely not random in all 4 seasons, and except these few points that are towards fall, but there's just a couple of points. Therefore we can also go ahead and change the alpha level. So let's go ahead and change the alpha to 0.25 and see if that tells us anything more. So now the data still says that most of the points are located right at the center, and there's very little movement towards either of these 4 parameters that are there. Now what we can do is use the special data frame that we have created to visualize this. So let's look at RadViz. Before we do that, let's look at the data frame. Here in this data set, we clearly see that for the column A4 or parameter A4, the values are 1000 for the category M, and that we should be able to see that in the data set. Also for the category O, all the values are 300, around 300, so they are much higher as compared to others. So when we plot this RadViz, and here we have the G as the data frame name, and the capital A is the which is the category. Then we can specify alpha is equal to 0.25, and then we can specify the size of the dots, let's say 90. Now here this is really interesting, and we can see that as expected the n values, which are higher around 300, they have moved to A2, and here we can also see that is the case. So these are the n values, they are much higher, and they are definitely moved away from the center, and they are closer to A2. Similarly, you can see that there are these data points M which are closer to A4, and here we can see that for A4, for the category M, we do have these values in 1000, and therefore these data points could be representative of that. All other data points are closer to the center. So that's one use of the RadViz plots, which could be really helpful in kind of identifying the clusters in a data set. Now moving on, let's look at a Bootstrap plot. What Bootstrap does is, if you are not familiar, let's say if you are trying to get a mean, Bootstrap mean of a particular data set, what it does is it will sample a couple of data points and calculate the mean of that, and then it will iterate through the data set to calculate the mean. For Bootstrap plot, we are going to import the library again. So from pandas.plotting, import bootstrap underscore plot, and now we are going to create the plot. So bootstrap underscore plot, and we are going to use the flowers data frame, flowers.iloc, and here we'll use just column at index 3, and the size is 50. That's the sample size, and how many times you want to sample. So let's say 100 times, and the color of the plots, let's put it at gray right now. And once we run this, here we can see that we get I don't know why it's plotting 2 times. It's the same plot, but here we can see that the mean of the data sets is looks like it's the peak is around 250, and we also get the median and mid range. And the more samples you get, so if you run this again, and if you get if you put higher number of iterations, say 10,000, then the uncertainties in the data are minimized, and you get a much narrower distribution as compared to here. So here the means varied from a lot. Now here the variation in the mean has reduced, so but it has a computational cost associated with it. But that's one way where you want to be really sure if that is the correct mean, and if any changes in the data would affect it. That's where we want to go ahead and use the bootstrap values as shown here. Next, let's look at autocorrelation plots. Autocorrelation, and what autocorrelation plots tell us is the data or time series data random or not. So we'll go ahead and import the library from pandas.plotting, import autocorrelation underscore plot, and we'll go ahead and use the flowers data frame first, flowers, and here the index that we have, it's a date time, so we should be able to use it. Now when we run this, let's see what the error is. Can only concatenate string, not float to string. Okay, that's correct. I should have put a comma there. Okay, now here what we can see is that if the autocorrelation is close to 0, it means that time series data is completely random, and that's what we see here. The data is pretty close to 0, so you can assume that the values in the column 3, which will be the production values for the flowers, is completely random. However, I've created another data frame which has some, or let's go ahead and create a new one. So np.sign, np.linspace, and let's go from 0 to 100, these data points. Now when we plot this here, we can see that the there is definitely some trend, because the autocorrelation values are above away from 0, and here we have the confidence intervals for 95 and 99, and they are much outside those. So in the second case, we can say that the time series data is not completely random as compared to the first case where it is close to 0, so that's likely random data. That was it for this video. Hope you all learned how to create different visualizations for multivariate data sets, and how we can identify clusters in data sets using these visualizations. Please like, share, subscribe. I hope to see you all in the next video, where we'll look at some another topics in Pandas visualizations. Thank you.